Hello, eCognition users and customers out there. We have an exciting webinar planned for today. I have a guest speaker with me, Dr. Jeff Groom from Aarhus University in Denmark. Will be presenting some of his research here in this webinar. For those of you that don't know me, my name is Keith Peterson. I'm the product manager for Trimble eCognition. And today we have a very interesting topic. We're going to be looking at working with time series image data as frames within eCognition. So an overview of what will be covered in this webinar. First of all, just a brief introduction to the eCognition software if there's anybody out there that's still not yet familiar with it. Then I'll introduce the concept of frames, and then I'll hand over to Jeff, who's going to present this really interesting research that I've been happy to get a hold of, and then we're going to have some questions and answers. The rules of the webinar are you are all on a listen-only mode. That's not a mistake. But if you have questions, you can ask these at any point during the webinar. Use the question dialog of the GoToWebinar interface, and can ask this question, and I will see this list. I will be collecting the questions as we go along. We'll take a few breaks and ask questions, and we'll save some questions for the end. So again, please feel free to ask questions at any point during the webinar. We'll be here to answer those. Second piece to state is that, yes, this webinar is being recorded. So if you miss some information that was in the webinar, do not worry. You'll be able to view this recording at Trimble Geospatial Webinar Archive after the fact. That's always been the case for our eCognition webinars. Other than that, I think we are ready to go here. So I'm going to jump right in and just give a brief introduction to the eCognition software. So for those of you out there that maybe not too familiar with eCognition, today we're going to be using eCognition Developer, or we're going to be showing work that's been done in eCognition Developer. This is a part of our eCognition suite. And eCognition Developer, we can think of it as a large toolbox that provides tools for advanced analysis, for doing various geospatial applications. Really, what we're doing is we provide tools to transform that geospatial data, so image data, LiDAR data, vector data. We can mix and fuse all those data sets within eCognition, but we can transform that data into a valuable geo-information that can be used in various settings. So that means we can take our image data or elevation data, for example, we can combine these, we can use this to explain and extract what's going on in the landscape, to create land cover maps. We can look at impervious surface maps, or even go after individual objects and extract single trees and things of that nature. That's eCognition in a nutshell. If you're really interested in getting more details, please visit our website, www.ecognition.com, and there's a lot of material there as well. So like I said, the topic of this webinar is working with time series data as frames within eCognition. So let's just review. This is something that's not often used, or we don't often see people using this. It's an older technology available within eCognition, but it's kind of tucked away, hidden gem, if you will. So let's just review what are these concepts of time series and how they're handled within eCognition. So within eCognition, we have maps, and maps allow us to organize different data or areas or areas of different resolution within a single eCognition project. So an eCognition project can be composed of different maps. What this really does is it gives us an environment to really increase our flexibility as a rule set developer for tackling these complex analysis tasks. There are several, or we can think of the maps and say it's three types. The first would be a multi-project map. This is where the project contains data independent of data in various maps. So we can put different data sets into different maps. This is a concept that will be relevant for this topic of the T dimension or time series analysis. We also have this grayed out multi-scale maps. This doesn't pertain to the time series analysis that we're going to be seeing here, but here your project contains a copy or subsets in these other maps. Excellent way of doing some rule set testing or say result backups and stuff in those different maps. Finally, the third type is what we call a multi-dimensional map. And here, these are projects that contain our time series data. So again, the two types of maps that are relevant for this T-dimensional analysis are multi-project maps and multi-dimensional maps. And just a few other good to knows here before we get into this is eCognition maps contain and represent the object hierarchy. So your image object hierarchy that you set up, your class hierarchy, that is also represented and contained within the individual maps. It is also possible to transfer object hierarchies between maps. So even though these maps exist independently of one another, you can transfer the information from one map to another with a synchronized map algorithm. And finally, maps cannot be analyzed in parallel. This is being in contrast to, say, a workspace where you have multiple projects contained within this workspace. If you have more than one eCognition server license, for instance, these multiple projects can be processed in parallel to one another, but since the maps are contained within a single project, they are not being supporting parallel processing of the map environments. So first section here, a little bit more detail. These multi-project maps here, two examples of a multi-project map. We see workflow A, workflow B. Workflow A is not something that considers, say, the T dimension, but it's a good thing just to be aware of. Within workflow A, we can execute our various analysis strategies on different data sets or areas without using eCognition server. So by putting these into two different maps, as you can see up here in the graphic, scenes from several regions are stored in independent maps. This is great for doing testing any type of analysis that you're working on, and really a good thing to consider in the development stage of your rule set. And again, you can stitch results of independent data sets without eCognition server. This is also allowed with, say, this workflow A. When we think of the T dimension and time series analysis, workflow B is then a relevant example. So here we're linking objects from different time steps in different maps in a combined analysis. So we have our scenes from say T1 and T2. We can do independent analysis of these, but we can link the objects between these two maps to one another, and then we can combine those results in a final step. Then we have the multi-dimensional maps. Again, this is something that's very relevant for the time series analysis. Here, multi-dimensional maps, of course, available in eCognition projects, and they're really based on time series data, a sequence of 2D images, or even a sequence of video data, so those video frames that could be loaded. These maps, like I said, they consist of a series of frames, and each frame is then a 2D image. And each time step or each image will then be available as an eCognition project. Okay, so each frame is its own project within eCognition. And how do you create these? Well, you can set up a customized import routine to create this time series workspace. So customized import routines are only available within eCognition workspaces. And then you just look at the frame parameters that you'll find in some of the help literature. And like I said, eCognition offers this this very nice ability to link objects from one time frame to another. So we're linking the objects across these frames within the projects. And just some examples here. This is what you can use to calculate, say, moving distance of an object or the direction that an object is going over time. And of course, the changes. Is it a new object? Has an object been moved from one frame or to the next? And then just an important thing to note here, when you set up your project as this multi-dimensional format, rule sets will be executed on all frames of the project in parallel. So here, because I'm setting up my frames in a workspace with individual projects, here then the rule set will be executed in parallel on the various frames, as opposed to the approach that we saw in workflow B, where I'm working with independent maps within a single project. Okay, so those are some of the differences and nuances that we need to consider when working with some of this time series data. So I don't want to steal the show. We have an excellent guest speaker here. I've had some great communication with Jeff over the build up to this webinar, and I'm really excited to learn about the research that he is doing. Just a brief introduction. I'm sure Jeff can explain much more about himself than I can, but Jeff is a senior researcher at Aarhus University in Denmark. He's been working with remote sensing and GIS, mainly as it relates to terrestrial ecology, and doing this since 1987. He is currently in the Institute of Bioscience, and previously worked at the UK Institute of Terrestrial Ecology, and then went on to Denmark's National Environmental Research Institute. And his work includes both the production of specific project required map data sets and exploration. So, perfect environment to use eCognition in producing these results, but also looking and reviewing software. And he's been using eCognition since 2008. It's excellent to see someone who's been using the software for as long as this. He can really speak to a number of aspects of the software. And Jeff, I will now hand over the presentation to you. Just give me one moment as we change the presenters.
Okay, so I hope that people are hearing me now, and I will go into my slides. So thank you everyone for joining this today, and thank you, Keith, for that fantastic introduction. I've not tried this way of presenting my work ever before, so I'm very excited to be part of this, and I'm excited to see that a good number of people have tuned in for this. I hope it all goes very smoothly. I'm going to have a number of slides to start with, and then we'll go into some semi-live demonstrations using eCognition to demonstrate three aspects of the use of frames. As well as thanking Keith, I'd also like to thank Matthias for some help in getting started with frames. As a bit of background, I'd just like to say that as with a lot of things, this all started when a colleague of mine who has a mass of time-lapse photography came to me and asked if I was interested in working with those image data for his project. And yes, of course I was. And I was at that time very slightly aware that there was something in eCognition relating to time frames and time-lapse photography. I'd never used it up to then, but I just heard about it. So I had time on my hands, so I dug into it, into the task in that way. And sure enough, I discovered it was possible. And I got it working. And then I came back to it 6 months later, and lo and behold, it didn't work anymore. I couldn't load the frames in the way I had before. So that's when I got involved with Matthias from eCognition. on a support ticket, and he helped me get it running again. And I'll mention later on one of the slides what the problem was there. And it was then Matthias who suggested that this could be a good topic for a webinar, and I took the bite on that, and that's where we are now. Christian has also helped with helping me understand one aspect of object linking, and then Sebastian Glaser has also been involved in making sure that quite recently I had functioning up-to-date licenses. Now all my work I do in eCognition is either with a developer or server license. So the developers are in the demos are in developer. They're not in Essentials. I've never used Essentials. I don't know quite how Essentials work. So I apologize for anybody who is only using Essentials, that some of this might be unfamiliar and may not be so easy to translate over into their work with Essentials. And also the rule sets in my demonstrations are all made using via the process tree. I don't use the analysis builder, for instance. So that might be another difference between myself and how some other people work. And my rule sets tend to be very long, hundreds and thousands of individual lines. That's probably because I'm a very bad programmer, and it's very sort of brute force programming. We won't go into the whole hundreds of lines detail of in the demos, but just to be aware that yeah, I do things probably in a less efficient way than some of the super experts who work at Trimble eCognition do things. So hopefully, what happened there? Yes, here we are. Next slide has come up now. I don't need to go over so much of details about myself. Keith has already done that. I'll just say how that the place I work is now part of Aarhus University. It was until 2007 a public sector research institute called the National Environment Research Institute. What has happened with that change is that we have gone from mainly doing research, advisory and monitoring work to doing research, teaching, advisory work and monitoring. Where I'm located is here in Eastern Jutland. The other locations of the institute are at Silkeborg and Aarhus and Roskilde. Here's Copenhagen for reference. And yes, this is where I work. I'm really pleased to be working in such a delightful building and setting. And what we do there is a lot of it's wildlife ecology and biodiversity and conservation work. And our use of remote sensing and GIS is very much driven in a bottom-up way. It's driven by the needs of understanding mainly Danish biodiversity and wildlife and biodiversity management and conservation issues. So if we do a lot of work relating to, say, the requirements of the Danish hunting regulations, the EU habitats and birds directives, Ramsar, those sorts of things. The coordinates down here, I'll just draw your attention to the second one of here. It might be the most useful to look at first if you do follow this up. That is sort of the agency side of our work is an organisation called the Danish Centre for Environment, and that website there will probably more fully explain the types of work we do. So I want to start by sort of covering a little bit of what might be considered as the sort of classic time series arena. Time series studies have been part of remote sensing for many decades. There's nothing new in that. Most remote sensing textbooks will very early on discuss the resolutions that define a remote sensing system: the spatial, the spectral, the radiometric, and the temporal. And repeated imaging of areas by satellites and aerial systems has been part of remote sensing for many years. And it's been applied, temporal analysis has been applied to many aspects of monitoring and change detection in a wide range of requirements. And I'm listing just a few of those here on that slide. The significance of eCognition for temporal analysis, change detection, was realized quite early on in eCognition's history. So, for example, back in 2004, Thomas Blaschke from Salzburg made a paper, or several papers, but this one, for instance, which is on the eCognition website, laying out a framework for change detection based on image objects, which sort of summarizes all the types of changes that can be considered and can be analyzed in a platform such as eCognition. And there have been many examples over the years in research papers and demonstrations and on the eCognition community of just how time series analysis can be made, such as in some of the ways that Keith was describing in terms of using multiple maps or simply having objects and sub-objects, with the sub-objects representing different time steps from the image layers. And there are several good demonstrations and examples of those types of analyses on the community website. However, things have moved on a little bit from the early days of remote sensing. So I now sort of think in terms of a sort of new time series arena, driven by all the sorts of technologies that have come along in the last 10 years, miniaturization, battery-powered everything, robotics, and new sensors. So we have a lot more possibilities of collecting image data now. We still have satellites with sort of very high resolution, spatial resolution, and even with can be programmed to do weekly repeat coverages. And we have UAVs, drones that give a very versatile way of repeat sensing of areas. And then we have the whole sort of mobile street imaging and GoPro type of technologies to gather data on the move. We also have more static modern systems, both for indoor and outdoor, that use technologies such as time-lapse and then movement or heat or sound triggered imaging traps. And these are getting to be more and more used in areas such as wildlife surveillance, looking for monitoring and presence of absence, or looking into nests and being activated when a parent bird comes back to a nest and things. And also in studying ecosystem processes in terms of vegetation phenology, insect dynamics, which is the subject of the use case in this webinar. Also bird colony activity. And then we have systems which are probably more indoors, which go to sort of very high time-lapse rates of hundreds and thousands of frames per second for use in capturing all sorts of physical, chemical processes to understand just what's happening in those. And then there's also all the tracking of individuals and vehicles that is now part of modern life. A further aspect of the new arena is simulation modeling. We do a lot of simulation modeling in our work here at CALU. This is individual-based models of animal organisms in modeled landscapes. And those simulation models may be run at a sort of a 10-minute or a 1-minute interval, updating the life and death and breeding success of the individuals in the landscape. And various aspects of that modeling could be output as image data, which then could be analyzed in a frames type of way. We haven't done that yet, but it's a possibility that I've realized recently. Two examples of modern time-lapse photography for ecosystem processes. The first one is an example of cliff bird colony nesting, breeding success, and looking at colony size. And that's the work of one of my colleagues, Flemming Merkel and his colleagues, in collaboration with the Greenland Institute of Natural Resources, looking at cliffs in Greenland to study the birds on those cliffs, mainly birds such as guillemots and razorbills. It's been going on for many years, and it's been done in the old way of people sitting with binoculars on the cliff top, observing the birds, making notes. But since about sort of 7-8 years ago, that's gone over to an automated time-lapse photography method that produces a whole stack of images of the same cliff, maybe taking a photo every few minutes or something. And Fleming and his colleagues, they've worked out ways of analyzing those, not actually using eCognition, but other ways of, I think, probably doing their own programming in Python or something. So that's just one example of modern time-lapse photography for ecological processes. But the example the other example, which is the one which is the focus of this whole work that I'm doing, and the use case in this webinar, is related to flower phenology and insect pollination. This is the work of my colleague Thomas Hoyer, whose research focus is the Arctic ecology and what's happening in the Arctic ecology under climate change scenarios, and in particular how the flowering and insect visitation is changing under climate change. So if the flowers are flowering earlier, are the insects arriving to pollinate the flowers and therefore enable there to be seed set? So starting from a small study 2-3 years ago at a number of sites, he's now last summer had 80 cameras set up at various locations in Greenland, taking 1 picture per minute. So each camera is on a sort of tripod setup and is looking down at a small area of ground and capturing 1 image per minute. So I think in one season, those 80 cameras will have collected 50 terabytes of image data. And he then analyzes the results in terms of seeing how the sequencing of insect visitation and flowering is changing with different aspects of climate change. The work is funded by a number of Danish research institutes, Carlsberg Fund, Willem Fund, and the Independent Research Fund, and has already had success with publications in IEEE journals and also a couple of times articles in Nature journals. Here's a video that runs through a couple of days capture of that type of image data. So we see how the flowers move around a little bit. If there's lots of wind, they might move around a bit more. And if you're very quick, you might be seeing insects come and visit. It happens in just a few frames, maybe, that an insect is present on a flower. And we're running through at 1 frame per minute through, I think, 1.5 days here. We're about halfway through the sequence. There's some flash photography used sometimes for when there's poor light conditions. Yeah. So in these 2 or 3, yes, we're starting to see some flowers begin to wilt now. So even in this 2 or 3 day period, some flowers are going from being a full flower to being a wilt stage. But I'll explain more about that next. Stop that. I'll take a small pause here and ask Keith if there's been any questions come in so far or comments that he'd like me to field.
Jeff, thanks. The moment, there's just a few questions. One, again, was will the webinar or the slides be available? And the slides themselves, no, but of course you can see the recording. Again, that's going to be in the Trimble Geospatial Webinar Archive for anybody who's monitoring that little questions window. Someone else asked what the link is to that archive. You can check that out in the answer. It's just geospatial.trimble.com/webinars-home. So you can go in and pick up this archived footage a few days after we're done here. And Another question, we have some people that are eager to see how this works in eCognition. This will be coming later in the webinar. So to this point, Jeff, I think you're going to show a bit of it, well, maybe not in the software itself, but you're going to be showing and explaining how this is working within eCognition, sure. Correct?
Yeah, that's right. Yeah, we'll come to that. We'll get a good dose of real live eCognition demonstration later on.
Excellent. All right, then I think that wraps up the questions at the moment. I'll continue to field some of the questions here while you present. So please continue.
Thank you. Right. Now, in order to understand the use case and to understand how eCognition is being used for that use case, I have to explain a little bit more about the task that I've been tasked with by my colleague Tocker. I said that one part of it is to detect the insects visiting the flowers, but that's actually being handled by other people using other methods. Tocker asked me to see if I could follow the development of the flowers. So I've put together a small, almost like a fairy tale story here to try to explain that in a simple way. I hope it's not too simplistic. I hope it's not too patronizing, but I think it's a nice simple way of understanding the use case. So I'm going to run through about 7-8 slides now, almost as a children's story. Once upon a time, there was a flower, a beautiful dryas flower, and there is a photo of that flower. The photo of the beautiful flower is a frame in a time-lapse set of photos. Earlier in the set, there is a photo of the beautiful flower as a bud. And later in the set, there is a photo of the beautiful flower when it has wilted. And if an insect visited it, later still, a photo of the beautiful flower as a seed torch. A good fairy called eCognition came by and made the bud, the flower, the wilt, and the seed torch into image objects. And the good fairy gave each image object a unique name. And the good fairy enabled each image object to talk to each other unique image object. And the good fairy enabled each image object to ask the other image objects questions, such as, "Hi, I'm bud number 2. How many frames forward was I first fully covered by you, flower number 9? Or, "Hi, I'm a flower. Was I, within 6 frames forward, ever at least 50% covered by a seed torch?" Or, "Hi, I'm seed torch number 4. How many frames back was I at least 25% covered by you, flower number 9? And thus, the good fairy made a database of which flowers got pollinated and when they became a seed torch. And the object's polygons, or the bounding boxes of interesting objects, were sent to a new land of milk and honey. So once upon a time, there was a flower, a beautiful dryas flower, and there was a photo of that flower. And now there is also a time-lapse, object-based image analysis concept and workflow. And the flower had many flower friends, and the same story and analysis can be made for each of them. And all lived happily ever after. So I hope that's given an idea of what this use case is all about. So let's now examine just how eCognition enabled the key stages of that. Well, the first key stage was that eCognition created image objects of the buds, the flowers, the wilts, and the seed torches. And this is, of course, what eCognition is really good at. It's the basis of eCognition, making objects in images. The extra element here is that the images are arranged in eCognition as a frame set. The next key part is that the eCognition enabled each object to ask the other image objects questions. How does eCognition do that? Well, it's via the use of these object-object links, which Keith was describing and mentioning in his introduction. So, for example, if we take that question, hi, I'm a flower, was I within 6 frames forward ever at least 50% covered by a seed torch? That's actually done in 2 steps. First of all, is making the links, creating links between objects. And then second step is using those created links to take an action based on a certain interrogation of the links. So we see it in a little block of eCognition rule set code here, with the first step being this part here. It's a loop. I'll explain that a bit later. And then the second step being the action based on an interrogation. An interrogation, could call that a query, if you like. So that first step of making the links between the objects, that's done by the eCognition application that's called Create Links. That's shown by that symbol there. So here is that block which does that. It's run as a loop. So it's a loop running from -1 to -7. So saying that stop the loop if the loop variable will carry on the loop if the loop variable is still greater than -8, and then the loop variable is getting decremented by 1 each pass of the loop. So the first thing to note within the substance of the loop is it's important to clear the special type of class that is created by a create links operation. These are sort of link object classes. They're special forms of classes, and they will retain things unless they're cleared beforehand. So it's important to delete them to make sure they're sort of initialized first. And then the create links line itself. So this is saying for all F objects, link to S objects, the seed torch objects, and using this defined shift parameterization. So the shift is defined in the GUI for create links down here. So it's an X shift, a Y shift, and a T shift, and the T shift being the loop variable. The other things to note here is that in these settings here, there's 2 options under link to. That could be either all or best, similar to some other operations in eCognition. And secondly, this parameter here, overlap calculation, has these 6 possibilities that can be used there. Otherwise, it's a standard sort of eCognition GUI with a domain side and a parameterization side. There's one, well, first of all, I'll just mention that there's this diagram in the reference book that kind of explains the relationship between what's called the current object and the candidate object. That's a nice illustration of that. There's one aspect of this I want to raise with Keith or other people in the eCognition team. It's that up until the latest version of eCognition, there used to be a 4th line here for a Z position shift. And that seems to have dropped out. There might be good reasons for that. But I can see up here that we've still got 1, 2, 3, 4 positions declared in the resulting command line of that GUI. So that might be something that we're worth finding out a bit more about what's going on there. When objects are linked, and if an object is selected, then linked objects appear with a green outline. So for instance, take one of the sea torch objects on frame number 8. That has linked to flower objects on frames 2, 3, 4, and 5. So that is, let me see now, maybe I should have written 1, 2, 3, 4 there. 1, 2, 3, 4, 5. You can see the ones here, the frames where it's found an object linked to. I may have some mistake on that there. And you can see that there is a green outline around them, indicating a little bit like as it is with PPOs, parent process operations. The green outline indicates the sort of associated object. I don't know whether it's at all possible to change that green outline to some other color. I've been looking for possibilities for that because, of course, in a situation like this, it's quite hard to see those green outlines. So it'd be excellent if there was a way of changing, varying the color of the outlines that appear for the linked objects.
Just jump in, Jeff. Yes, I believe you can change the color of the outline color. I know you can for the image objects. So the standard default color is typically blue or black, and depending on what setting you're working in. For linked objects, where we have a default of a green color. I believe this can be changed as well. I'd have to look into it further. There's some of these deep settings down in that, but I've taken a note. It could be our next tip of the week. So
yeah, good. So that was step 1. Then we come to step 2, and that's taking an action based on a query of the links made at step 1. And in this case, for example, it's an object class name assignment, so a relabeling of an object based on a query. Just note that out here means looking forwards, but we'll come back to that in a moment. The feature that's been used there is one called linked objects count, and that's one of a set of object link statistic features that are available in eCognition. And I must admit, of the 3 object link statistic features, it's the only one I've explored so far. And the last of those there, link weight to PPO, that just frightens me. The idea of combining object linking analysis with PPOs is just scary. But maybe I'll take that up one day. So back to the implementation in this use case. I've used this linked objects count feature, and the GUI for that is really quite simple. You just declare which of the link classes you want to use, the direction of the link being either all in and out, or just out or in, and then how far the query should run over, how many frames. And you can see there that this is interesting because the max number there is 1 short of a million. So that suggests that eCognition could accommodate frame sets of up to 1 million. I haven't tried that yet, but that might be what that's suggesting. There's various parts of the user guide and the reference book which explain what's going on here, and it is a little bit complicated. But these 2 figures here are the key figures for understanding what's meant by in and out and all and max distance and things. I'd like to take a pause here again and ask if there's any questions.
Jeff, we had one interesting question come in here, and that was just in general, how were you able to identify the flowers or the buds themselves in the first place, say in your first frame, in order to then link them?
Well, just the same way as if it was just a single image in a single map in a single project in eCognition, a whole stack of threshold, what are they called? Threshold segmentations, multi-threshold segmentations, and pixel-based resizings and mergings and resegmentations. Say it's about 500 lines of code just to get to that point. That could be done a lot simpler. And as we'll see when we come to the demonstrations, even for 9 frames on my laptop computer here, it takes 10 minutes to run through that. A lot of that time is actually for one particular step where you've identified all the flowers, but some of them are double flowers. You've got 2 flowers that are overlapping, and they appear initially as one big flower object, and we need to split them. And there's a whole lot of different situations where that split has to be made in different ways, and that step itself takes about sort of 5 minutes of the 10 minutes. But it's a whole stack of standard eCognition rule set processes, and that could be done in probably 100 different ways.
Great. So just a sort of a mix of looking at the, let's say the spectral characteristics of the image, and then mixing that, of course, with the advantages of object-based image analysis, where you have you can look at shape and size and neighboring objects relationships to then take the initial, say, classification and then refine that with something like pixel-based object resizing, etc.
It has to be done in quite a sensitive way because, as you saw in the video clip, these frames have quite different lighting conditions, and this is a completely natural environment. So all sorts of strange things happen. There's the shadowing of the tripod arrangement that gets in the way. So it took a while to get a rule set block that did that in a satisfactory way. But it's all heuristic by trial and error, just until something works. And who knows, the next image I tried on, it might not work. But so far, it's been successful.
Great. Another question came in regarding the data and then the cameras. Is it do you use any type of geocoding for the photographs?
No, I mean it's completely static. Each photo is, and it's a very small area. It's looking at just maybe less than a meter square, probably. Very high resolution. The images are, I think, 6,000 by 3,000 or 4,000 pixels. The site, of course, is geolocated, but no, we're not working in strictly geocoded images here.
Okay, and then just a follow-up to that was, how would you account for a movement of the camera over time, or is it positioned in such a way that it won't move?
It's I've not been out to Greenland, unfortunately, to see how it's done, but from the small SketchUp of the rig that was in that slide a few slides back, it looks like it's a fairly solid 4-legged arrangement with a horizontal bar, and which I guess is tied down to the ground with pegs and things so that it doesn't move at all, even in Greenland conditions.
All right, great. Then there are a few other questions, but we can come back to those later. So please continue the presentation. Maybe we'll get the answers to those as you advance.
Right. Good. Thank you very much, Keith. So to the demonstrations. A few slides which introduce us to those now. There are 3 demonstrations I'm going to use, and that's done as three different eCognition workspace setups. The first demonstration is really just to get us a little bit familiar with working with frames in eCognition, showing how some of that works, some of the basics of handling frame sets in eCognition, feeding them out to different maps and things. Some of the basic feature properties of images that are input as frames. The second demonstration picks up with a rather simple feature that is present in eCognition that enables us to do some frame-to-frame analysis, and that's a feature called overlap of two objects. So that demonstration focuses simply on that single feature. The third demonstration is the most developed, and that's really my sort of the state of the art with this whole application that I'm doing for my colleague. That's where we are at the moment, and that's slightly well. That's the more advanced frame-to-frame analysis using links, object linking. Keith has already said something about what frames are in eCognition, and there's a handy small section in, I think, probably the user guide, which describes the sort of basic eCognition image data model, and in that the possibility of time series data is clearly mentioned. Now, some of you who have been using eCognition for a few years may be aware that there has in the past been something referred to as slices in eCognition, and this dates back to when eCognition was a software for both environmental science and for life science, for medicine. And in medicine, there in lots of situations, such as with CT scanners and biopsy slices and things, thinking in terms of slices and needing to do image analysis across slices. So there was this concept of slices in eCognition for many years, and I can see that that's now sort of dropped out of the user manuals, and I can't find a single use of the word slice in the user manual or the reference book now. So I guess that's a sort of recognition that there may not be so much call for thinking in terms of slices. But if there are people out there who do need to work in terms of slices, as far as I can make out, slices were very similar to frames, and so the frame functionality could indeed also be used for slices as well. This is part of demonstration 1 still, getting a time series into eCognition. It seems it is possible to do that as a single project. I picked up on this part of the user guide, which explains something in relation to sort of modifying the layer properties in terms of the number of frames, frame distance, etc. I've not tried that. Well, I did try it, but I couldn't get it to work. That's not a problem for me, because instead I always form these frame sets in eCognition via a workspace. So I have a form a workspace, and then I use a customized import to enable the workspace to form projects in which sets of images are understood as frame sets. And the key part of that is the search string and the use of this reserved variable, a token called frames or frame. It's set within curly brackets. It's one of the sets of so-called blocks which can be used in search strings and in scene names. So I'm using then the frame there in the scene name. That's explained in section 9.1.2 of the user guide, if you want to see, and you can see there all the other possibilities of using blocks in customized import. But that's what I use to form my frame setups in eCognition. Yeah, this is where I had to contact support 6 months ago or so, because after having it work in earlier versions of 9.3, suddenly it stopped working, and I couldn't understand that. I couldn't get frames to load. So I contacted support, and we found out, yes, there was something that happened in some of the later versions of 9.3 that disabled the possibility to load frames, images as frames in this way. That has been fixed in 9.4. We'll jump to the third demonstration with a few slides about that now, and just a quick overview of the rule set for that. The first part there is all the stuff which will be covered by the first demonstration. The part there is this issue which we had the question about a few minutes ago about how the objects were initially formed, and it's about several hundred lines of basic eCognition code that do that job. And then I've got two versions of the essence of demonstration number 3. In one case, we're just simply finding for every flower object the ones which were associated with a seed torch object later down the frame sequence. The second version of that is a little bit cleverer in that it realizes that, well, we don't need to do that for every single flower object, because often the same flower is represented on a sequential set of images. Therefore, all we need to do is to find the flower object of a flower, which is its largest representation of that flower, and use that for the query into finding out whether it's been turned into a seed torch object. So that's a sort of a development from that point to that point, and we'll be able to explore both of those in the demonstrations. That explains that last point in a more pictorial way, that in the first solution we're asking for every single flower object, did you change to a seed torch? In the second solution, we're first of all looking at sequences of objects of the same flower and asking, well, which of you is the biggest? It's this one here. Right, we'll just ask you, did you turn to a seed torch? Regarding the link objects, there's a few good demonstrations of that on the community if people want to really get into using the object links link functionality. The rule set here is of Christians is fantastic. You have one point in that you have like a lighthouse beam running around a circle of objects. Fantastic work. Okay, that ends the slides. Before we go to the live demonstrations, I'll just ask if anybody's got any questions or comments on at this point.
Sure, Jeff. One interesting one came in here. You mentioned earlier that if you look closely in some of the video sequence that you showed, that frame-by-frame sequence, that it was possible to see individual insects coming to the flowers. Have any attempts been made at trying to identify what flowers these insects prefer? Do they prefer one over the other, or even any type of classification of the insects themselves? Were they bees versus some other type of insect that might be flying around in the environment?
Yeah. First of all, regarding the flowers, the flowers in this use case, which I've been working with, are all flowers of this species, Dryas octopetala, the mountain avans. This grows as large clumps, which can be sort of like a couple of meters across, and then hundreds or dozens or hundreds of individual flower heads sort of pop up and wilt and seed and everything from that clump. So there are no other flower species present within that clump, within those test studies. However, for other locations of the 80 cameras that we used last year, they've gone to situations where there is a more varied set of flower species present. And that will be a new challenge to see how successful it can be to capture as objects those different species. It's not one I've come to yet, but possibly I'll get a chance to try that at some point. Regarding the insects, I could imagine to try to also capture the insects using eCognition, maybe once I've first of all identified the flowers that appear to have had an insect visitor because they've gone to seed. So I can focus in on just those flowers that went to seed and see when an insect visited them. And I can imagine several ways in which that could be possible in eCognition. However, I've not yet been given a possibility to explore that. because that type of question regarding the insects is being explored by other people who don't actually use eCognition. They use other facilities, such as quite advanced deep learning possibilities. I know there's deep learning in eCognition now, but the situation, I think, is that there exist now quite sophisticated libraries of thousands and hundreds of thousands of insects, such as from museum specimen catalogs, and these have all been imaged. And so for the purposes of deep learning applications, the necessary libraries have been created from such insects. So there are other people who are exploring that line at the moment. Maybe I'll get a chance to try capturing the insects with eCognition as well. We'll have to see how that goes. Okay.
Excellent, Jeff. Then look forward to the demonstration in the software.
Right. So I can come back to the show later, and we'll bring up the first of the demonstrations here. So hopefully everyone can now see a familiar eCognition workspace and developer interface. So I'm actually using the workspace load and manage data option here. So the workspace is as here, and there are then 2 projects in that. Those were loaded using the customized import, such as is shown here, which is the same as was shown on the slide a few minutes ago. What happens when you create a frame set is that a special type of folder is created. Let me see if I can find that now. It's here. See here. This is in the workspace environment of this workspace we're looking at here, and there's alongside the DPR folder, there's another folder called a DSIF. So that for each time a new set of images is loaded as a frame set, it seems that a new DISF file is formed there. I have no idea quite what it does, but just be aware of that, and it's nothing to be worried about if you see that suddenly appearing. That's how it should be. The way I have my data organized, just as a reference here, is that I have everything in input data folder, and then all the image data in a set of folders underneath that. So there's two projects here. You see, one is the set of 150 frames, and one is a set of 9 frames. And in the one for 9 frames, there are 9 JPEG images. So we can kill the workspace window and look just at the image now. So that was loading the frames. Then the next bit is getting the frames navigation toolbar. This can be got in 2 ways. You can either go to View, Toolbars and 3D, or you can use this command, and we'll use this command. You find the command from that part of the parameterization there. And that gives us this toolbar here. And that toolbar enables us to navigate through the frames. So working from right to left with this, first of all, there's 2 arrows that let us move frame by frame, forwards or backwards through the frame set. And then there's also a slider enabling us to move around the frames. And there are 9 images in this frame, and you'll note that the first frame is indexed as 0, and the last one will be indexed, if we could see it here. I can't quite see it. It's indexed as 8. Another button here is a sort of a movie sequence, so we can set it running through the frames like that, and stop it and restart it. So that navigation tool is a handy little way of working with frames. And you can see on the view window here that as we move back and forth in the frames, the frame number is shown down there. The next thing I'd like to show with this demonstration is how we can work with making frame subsets using a region variable. So if, for instance, I want to look at just a subset of the 9 frames, I can define that using a region variable and set it up as set by origin and extent. I'm cutting off the bottom part of the image, so I'm starting in Y at line 228, and then the origin of the frame set is 5 and running for an extent of 5. So if we run that, and then actually I think I've got it preloaded. No, I haven't got it preloaded. I will then make the new map of that and do a view settings. So that's main up there, and that's the new map that we've just created, which has just 1, 2, 3, 4 frames in it. So it went 5. It was original 5, 6, 7, 8, and they are now numbered 0, 1, 2, 3, and they correspond to 5, 6, 7, 8 in main. So that's one way of making a subset. A second way could be using the making a region variable via set by min max coordinates, and they're, yes, all the same except for that the max is not the extent, but is the last one in the sequence that you want to refer to. Here I'm putting 9. I think it's indexing to 8, so that it's not necessary to say 9 there, but it doesn't load a 9th from the 9th because there isn't one. If I run that and view settings, it's the same. We see the same again. 1, 0, 1, 2, 3. Yes, so there are 4 frames in the new map. Yep. But that can also be done via an object. So I don't yet have an object here, so I'm going to form an object in here. This is an object that's imported from a thematic layer. So I think to see the thematic layer, I need to go to frame number 1 on main. So there we have a thematic layer, a shape polygon that has been imported as a thematic layer, and I'm going to use that to make an object. Takes a few seconds to do the creation of the square object.
Jeff, well, that's I see it's run already, but a question came in here just in terms of how are you differentiating between bud, flower, and seed torch? But if you get to that later, then we can certainly save it. Just wanted to bring it up. We had
I can just give a quick answer that I have a full version of the solution where I do try to find all the buds and all the wilts, as well as the flowers and the seed torches. However, the 2 most crucial stages in this application are flowers and seed torches. So I'm not too hung up on finding all the buds and wilts at this stage. I have got some versions of the rule set where buds and wilts are also found, but we're not going to see so much of that today. Okay. Yeah, that was where let me see, that was making the object there. and then we can make a create a region variable that is taken from the domain, being that class which is the object label. Just put that on. That is has the, where am I? That should be, let's go to that and look at it like this. For some reason I'm not getting the, but that is that object there is the class AOI. So this command here, oh, there it is over there. We can see the AOI in the class hierarchy. And so this is saying make a regional variable from the domain being object of that class. And then that can be used to make a new map. There's 2 stages to this, though, that need to be explored. That, let me see now. Yes, first of all, we make a new map which is based on the max-min coordinates, and that's taking the object domain from the object, but then to restrict it to a subset of the frames, we then do it by the restricting the region variable definition by a second stage to restrict it to a certain subset of the frames. So 2 steps involved in making the region variable there. I've lost myself a little bit in here, but I'll try and see if I can get that to demonstrate. So yeah, so there we have a new map down there, which is just the part of that, which is, you know, that region variables are always rectangular boxes, so that includes the extent of the object plus a bit more down here, and you can see it's, get to one of them which is the same as that. Well, we did change the set of subframes that went into that, but you can see how you can make a spatial restricted map from your frame set, which is also a frame set based on an object. So that was just to demonstrate some possibilities in creating extra maps from your initial frame set. I want to show a few of the features in this demonstration, finally, that related to frames. So for instance, if we should have this up, it should be coming up, let me see. Yeah. For instance, should be more things showing up here. There are a number of specific features that show relating to frames, such as the I think I'm going to have to.
I believe, Jeff, you're in the classification tab. If you click on the features tab.
Oh yes, of course. Below. Yes. Thank you, Keith. Thank you very much. Great.
There you are.
There we go. There we go. So starting with the original 9-frame main map, we see features that are possible, such as the active pixel, t-value, the map origin, the map size, and the time series distance. And if we sort of then move through, actually those don't change at that point. But if we go to one of the submaps, and one of the ones which had objects on them, so if we go back to the first frame on that, where there's an object, and click on the object, then we can see various object related features coming up, which can tell us, such as, for instance, the time frame that a specific object sits on. So there's various features which enable us to understand and analyze what frames in the sequence we're looking at and working with, and what frames the various objects relate to. Final point here is that I've discovered that the relationship between frames and thematic layers for import and export is quite complicated. I've tried having a set of shape polygons which relate to the different import images, and even having a sort of a field in the shape attribute table which would tell a system which frame it's supposed to relate to. But I can't get that to sort of load in such a way that that polygon relates to that frame and another polygon relates to another frame further down the sequence. There's possibly some limitations in those in terms of those sorts of functionality. I'd love to hear that's not the case, but so far I've not seen anything otherwise with that. Were there any questions relating to anything that I showed in that demonstration?
There were a few questions that came in just in regards to can these concepts also be applied to other types of imagery or objects that we're seeing? You know, could we use it with satellite data in terms of looking at building changes over time? My general answer is yes. This is in this particular case, we're looking at the images of flowers. I assume they're in a TIFF or a JPEG format, something
They were
like that.
just standard JPEG format, yes.
Yeah, so eCognition supports this, and
yeah.
if you had a time series of satellite imagery, you could theoretically set up something similar and use these tools, these object linking tools that Jeff has shown here. Buildings is a great example. How is our urban landscape changing over time? Buildings being added to, the environment being removed, being built onto, things like that. Very similar to the way the flowers are shifting and growing here. So.
And there's no geocoding on these images, but I'm sure if it was proper remote sensing images with geocoding, it would load in exactly the same way, and except for that you'd also have all the geocoding possibilities to exploit in the rule set. Pixel size being metric meters, relating to metric meters and things. Yeah. Okay, that was that first demonstration. I'll now bring in the second demonstration. This is the one where we're just exploring one rather simple feature, which starts to explore the possibilities of object linkages. So here we have, we've made one object, this cross here, on frame 4. And then on every frame, we have, all the other frames rather, we have a grid of objects. I'm just going to pull up the toolbar. That's useful again. And move it over to here. I don't know if it's possible to have that as a default at all, but otherwise you have to just load it each time. So yeah, so we can see how in frame 4 there's that red object, but on all the other frames there's not a red object. So what I want to do is then to ask for cases on the other frames for specific relationships in terms of the overlap, and the feature that is used for this is this one here. So if I go to that comes out from relationships to neighbor objects and overlap of 2 objects. So that's actually below the class features, relationships to neighbor objects, and the last one on that set is overlap to 2 objects. So you create a new overlap to 2 objects feature to meet your requirements, and I've got 3 here which I'm using in this demonstration. So for example, for this one here, if I run this analysis and then do the view, so that's telling me how these all relate to the objects on the checkerboard segmentation, how they relate to the red object on frame 4. So, for example, that's got an overlap of a quarter. So a quarter of that overlaps with the red object. The whole of that overlaps with the red object. 75% of that overlaps with the red object. You can see the value here in the object table. So that's a very simple feature that can be used to analyze pairs of objects on different frames via an overlap of objects. The example here is in terms of the candidate object rather than the current object. And what that means is it's asking what proportion of this object is covered by individual objects that are being interrogated or queried here. So 0.07% something, 7% of that object is covered by that object there, whereas 23% of the entirety of that is covered by that object there. So that's a very simple feature that can be used to do multi-frame analysis of objects. So then we'll move on to any questions on that?
No questions have come in so far, Jeff, so please feel free to
we'll just carry on then. So I can see the time is running, so we need to press on, and we will move on to this one, I think. Let's see, let me just check. It's not on the screen yet, it's coming on the screen now. And this is where I'm doing the real analysis of my flowers, between the flowers and the seeds. So, for example, if we look at if we look here, I have managed to classify as objects all the individual flowers as they appear. And we can see that even where two flowers overlap, or where they are joined, they were originally a single flower object there. We've managed to split them into separate flowers. And then as we go through to the later frames, we're picking up the seed objects. Seeds objects only appear on the last two frames in this sequence. There's a few on that frame number 7, and then a lot on frame number 8. And then what we've done is we have implemented one of these create object links and a query on that. And let's see if I can find where that is done. That is done deep in here somewhere. We first of all neutralize the links and then create the links, and you'll see that that's familiar from the slide I showed earlier. It's a setup like that. In this case, saying overlap, minimum overlap required is 10%. Yeah. So that's making the links as a loop, and then using that to make an interrogation, a query, in order to reassign. Well, in fact, not to reassign, but to set, in this case, update a variable on each object. So the updated variable there is the one we're seeing here, which is an object variable saying seed to a flower to seed. So if that's a 1, that's saying that flower went to seed. If it's a 0, it's saying that flower did not go to seed. So we can click around on this and see if we take off the highlight, we see it's moving to the individual flowers, and you can see on frame 8 down here, judge that these all, the ones I'm picking on, have indeed gone to a seed. The last column here is showing what time frame, what frame the flower object is sitting on. And if we go down to the zeros, we can say take a reasonable sized one here, and and apparently that one lying here somewhere, I think, never went to a seed. So only that one there, lying in the middle there, no evidence that that went to a seed. So that got a 0 on that object variable. So that's the simple form of the rule set, where we're analyzing or interrogating every single flower object, irrespective of whether it's the same flower represented by several different objects on different frames. The last part of the demonstration is then to show where we have gone a step further than that, and sorry, no, not that one. I need this one, I think. Let me just take that down, just to bear with me for a moment. I'm getting lost in all my eCognition windows here. And it's going to be D2, I think, D2. Bring that across, yes. Bring that across to this screen so that everyone can see it. And in this case, on the last one, we got to that point there. Now we're going on to this point. So this is using another create object link operation in order to do that analysis, in order to determine whether a flower object is the largest of a sequence of objects of the same flower. And then once it's done that, it then goes on and does the same analysis as was in the solution form number 1, which was there. So if we do those 2 steps here, these create link operations and interrogations do not take very long. They take just a matter of a few seconds. And so we can see here we should be able to view the results of that. Yes, there we go. And we have now far fewer cases which are being analyzed and therefore categorized as flowers which went to object. You'll notice at the end of this there's an exports. I'm not going to explore that in detail, except for just to show something. This is relating to if you want to export from a frame set. There's a few things to be aware of. It's not as straightforward as you might imagine. So for example, here I'm exporting a frame sequence of images and then specific objects from that frame set. And yes, they do then sit spatially corresponding to that position in the frame set. So you can see from this that in eCognition, frame sets appear to be conceptualized or in terms of a data model, conceptualized as a film strip. Because when you export a set of images from a frame set, you get a film strip sort of a presentation, and then objects exported as shapes sit in their corresponding place on that. So if I say take away another object, that's that one there, representing that flower there, it's sitting spatially above the first frame. That's one way of exporting with one set of settings. But another way gives you something like this, where all your objects are thrown as export polygons into the space of the first frame. So I am not an expert in this export part of it yet, but that's just a point to be aware of if you do go down this line and start to explore export options. And that really is all I want to say and do and show in this webinar. Of course, there might be lots of questions that people have or comments that people have, and I'll be happy to field them as best I can now.
Great, excellent, Jeff. I'm going to just take back the presenter role from you. And we've Got a bit over on time, but I think we have some time for a few other questions. Some good ones have come in here. One question is, do you have one class for each stage of the flower development, or just a single class for the flower overall, all of the stages?
In those images, the appearance in the images of the flower and the seed stage are so distinct. The flowers are mainly sort of large white outer petals with a yellow core. I'm not a botanist, so I don't know the proper terms for these things. Whereas the seed torches are these sort of pinkish white, rather elongated forms. So it's quite easy to distinguish those and make flower objects and seed torch objects. Buds are also distinct in that they're small and white for this species. However, there are other small white things present in the image data. So I would, if I needed to map buds, I would think of using object linkage and querying in order to filter my initial set of buds to a final set of buds being ones that within a few frames have gone to flowers. And wilts can take many forms. Wilting is sometimes the center of the flower head turns a darker yellow and an orange. Sometimes the outer petals start to decay and go brownish or yellowish, but it takes many forms, and it can be a bit more challenging to capture the wilt stage as wilt objects. Again, I could use object linkage and querying to assist in that, but it's not so important in this task to capture every flower wilt object.
Okay, great. Another question was, this problem is not only unique to flowers, but a lot of other aspects of remote sensing is when we have two objects that get classified that essentially touch one another. Let's say it could be the crowns of trees, or even maybe two buildings that are neighboring each other. How were you able to separate, in this case, those two flowers? You showed that they were initially one large object, and you did a separation. I believe that you pointed out this was a piece of the rules that was rather processing intensive.
Can you give control back to me, Keith, for a moment?
I can certainly do that.
Okay, so it's in this part here where we're getting the flower and seed torch objects in the initial stage. And let's see, where is it now? Yeah, this part here. So if people are viewing this afterwards, they can see I'm going into stage 2.5, make one flower object to single flower objects. And I'm not going to go into open up all these blocks here, but people can see here some of the stages that are involved in solving that part of the problem. And it's a lot of pixel-based object resizing involved, growing out, say from in the initial flower objects, then finding the yellow cores, which are very easy to find because they come up very distinct in single image bands on this, and then from those cores growing out with various rules in order, say, for instance, where there are two objects that are together like these two here, you can see that the join line is kind of a midway line between those two cores. So it's in some ways quite simple, but there's always 10% of the cases which take 90% of the time to solve. Okay.
Another question came in here. We'll take a few more. Is try and get this one correct. Because plant stems, or sorry about my lack of botany knowledge, inflorescences grow over a couple of days, weeks. Are you able to still track the same flower over this time series, so to keep the initial object, essentially this initial object code across the time series.
Yeah, what I've been discussing with my colleague Tucker on this is that whilst the time lapse was done as 1 image per minute, for this initial stage of the research analysis of catching the flowers which went to seed torch, we don't need to take every single frame into that. We could take, say, 1 frame per 5 minutes or 10 minutes through several days in order to capture those cases which clearly went to seed and those which didn't. So that sort of will reduce the burden of that initial stage of the image analysis where I have to create the objects. And I do admit I've only so far run that on a 9-frame sequence, and it takes 10 minutes on my computer here. So that's quite an issue in some senses if we're going to have, say, 100 or 500 frames to work with. And it may be that I can do this whole initial stage of getting the flower and seed torch objects in a wholly different way, which it works a lot quicker and simpler. And that's probably something I'll be looking into next. But in principle, it could work over a longer time series of images representing several days or indeed the whole season. To say that it seems that the frame functionality in eCognition can take up to 1 million frames in. I haven't tested that yet. I have got sequences running to thousands of frames to see if I don't know. I think it would depend a bit on having a good computer with a good RAM and page size to accommodate that.
Right. I think it's also an excellent point of bringing up the stages of rule set development. You've spent a lot of time developing this very complex rule set, and typically I can speak to when we do internal development in our eCognition offices. We start out in a very similar way. We create a rule set. It looks very bulky and complex, and just to see, are we getting our concepts to work? And then we come back to that at a later phase and say, okay, I can solve the problem. Now I want to solve the problem faster. What can I do then to streamline certain processing steps and really accelerate the end results? And it's something we do quite frequently within our work and with other Trimble groups as well. So it's a common rule set step to do this over steps. One person has actually asked if you'd be willing to share your rule set. I guess my initial question, I'm sure Jeff, you can reach out to Jeff and contact him, but also consider that this rule set's designed really for a very specific purpose here. How transferable it would be to, say, tulips or some type of other flower out there would be in question, but I'm sure Jeff would be willing to.
And I would doubt whether many people have the patience to go through 500 or 600 lines of someone else's code to try to understand what the hell is going on. I try to annotate it as best I can so that I can follow what I'm doing, but I fully admit I do some perhaps weird off-the-wall things sometimes, which are completely unconventional, and I hardly ever use multi-scale segmentation in my work. I just can't understand what objects I'm getting out of that often, so I use things like multi-threshold segmentation and things.
Yeah, no, it's an excellent. What I love about this example is, first of all, it's not something we see every day. We're always looking at, say, that the geographic data sets are top-down aerial imagery or satellite imagery, or even a lot of scan data now in eCognition. So this one was a completely new use case that was just very interesting, and just shows the flexibility and the power of the tools that are available in eCognition to solve not only those, say, land cover classifications, which are complex in themselves, but also going out and handling completely different types of image analysis.
Yeah, and even sometimes if I'm faced with a task which is not initially, in terms of images, I think can this be reduced to images and then thrown at eCognition in some way?
Right, right,
That's
exactly. So I think to conclude, I would say first of all, if you have any, I see there's some very detailed questions on Jeff's work. I would encourage you to reach out to Jeff himself. I'm sure you'd be willing to correspond with people on how you've approached the problem and maybe give some tips
sure.
there. But we have to bring this webinar to a close. We've run over considerably, but it was well worth it.
Sorry.
No worries. I really learned a lot here. Linking objects was something that even though I've worked with eCognition for a long time and now developed the software, it's something that I hadn't gotten into myself. Everybody has their little areas of focus within eCognition. But just to sum up, again, this webinar has been recorded. It will be available in the archive for anybody who missed stuff. Moving forward, if anybody got interested to learn more about eCognition, we always have a number of different options out there. There's going to be eCognition training coming up. I believe the next one's going to be in Poland. Then there will be a training event in Sacramento, California. I believe that's going to be in June, but we could, if you write to us at support@ecognition.com, we can answer any of these types of questions. So eCognition training is an excellent next step. You can also check out the eCognition community. Jeff pointed out at the beginning there were some great resources that helped him on understanding the concept of maps and how to work with the linking of objects based on examples that you can find in the eCognition community. There are a number of tutorials there. It's free to join, and you can access information there. Beyond that, please consider all the material that we now have in YouTube. We have a beautiful video series called eCognition Deconstructed, where we take a specific algorithm each month and we break it down and we explain it to you, or we try to explain it in 10 minutes. Sometimes we run a little over, but there are lots of great resources out there to learn more. And that being said, I'd like to sign off for today, and I hope you enjoyed this webinar. Again, questions, please send those to support@ecognition.com. Our engineers would be happy to answer anything like that, and we could also, if Jeff's willing, to put you in direct contact with Jeff. And I'd like to just say again, thank you, Jeff, for sharing this. It was extremely interesting, and
You're
I hope
welcome.
everybody else out there is going to walk away learning from this.
Thank
Have
you.
a good day and good evening to those of you, and we'll see you next time in our eCognition webinar series.